All right, today's topic is when you have an electron configuration, for example, on here, and again, this is on in the electronic packet. We did the first part, which is how to do electron configurations. Now we're going to utilize that to figure out something that's called valence electrons. Now, first of all, just to reiterate, if you are given electron configuration, you should be able to easily figure out what element it is. So if you need to pause the lecture now, please do, to try to see if you know which element this is. All right, so how are you going to do that? You're going to take the superscripts and you're going to add them together because the superscripts are the number of electrons. So for this one, it'd be 2 plus 4, which adds up to 8 electrons. Now, if they say this is an atom, if it's an atom, the number of protons equals the number of electrons. So this element must have 8 protons. Look up the atomic number of 8, and this is the element oxygen. Okay, so from the configuration, you should be able to figure out what element it is simply by adding up the superscripts. Okay, now what are valence electrons? If I look back at the Bohr model of the atom, we have our positive nucleus, and then around that nucleus we have these rings, which are called energy levels. If an electron is on the first ring, it said n equal 1, that's the first energy level. N equals 2, N equals 3. As electrons get placed further and further from the nucleus, they have more and more energy. So for an electron to move from one orbital to another, or an energy level to another, it must gain energy. Vice versa, when it moves down, it releases energy, which is what your lab for this week is going to look at, these flame test colors. Well, for magnesium, you'll notice here's the electron configuration. The number out in front tells me what energy level. So magnesium has got electrons on the first energy level in the 1s2. Then it has 2s2 and 2p6. Both of these have number 2 because the second ring, the first ring only has the 1s orbital. The second ring has got the 2s and the 2p. And then the 3s, 3p, and 3d are on the next energy level. So you'll notice that magnesium has got electrons on the first ring, the second ring, and the third ring. The valence electrons are considered the electrons that are on the outermost or highest energy level. So magnesium has got the highest or valence electrons are found in the third energy level. And therefore, there are 2 electrons in energy level. Okay, if I do the complete electron configuration, I'd have 2 electrons on the first floor. I'd have 8 electrons. On the next floor, and then there would be 2 electrons on the third floor. So the outermost ring has got 2 electrons on it, so we would say that magnesium has got 2 valence electrons. It's the valence electrons that dictate the bonding of an element, and this is why electron configuration is so important. Because magnesium has 2 valence electrons, that will tell a chemist what it will potentially do. Is it more likely that the magnesium will want to lose or gain electrons? Because all elements want to reach a noble gas. Noble gases have 8 valence electrons. So all elements want to lose or gain electrons so they can get up to 8 electrons in their outermost shell. So magnesium has got a couple of options. Either magnesium could gain 6 more electrons, or it could lose 2. If it were to lose the 2 electrons on the 3s orbital, then the remaining orbitals, the first floor and the second floor, would be completely filled. So what do you think is more likely, to gain 6 electrons or to lose 2? And the answer is to lose 2. And therefore, we know that magnesium, when it becomes an ion, it typically would do so by losing 2 electrons and forming a positive 2 charge. And that is because of the fact that it has a lower number of valence electrons. Okay? So the valence electrons are the electrons on the outermost ring. The other electrons are said to be inner shell electrons. For magnesium, it's got 10 inner shell electrons, those that are found on the first and the second floors. Those are considered the inner shell electrons because they're inside the third energy level. Okay? So take a look at iron. Look at the valence energy levels. How many valence electrons does iron have? This one's really tricky because you'll notice that it's got first energy level, second, third, fourth, and then third. Most students will want to group the 4s2 and the 3d6 together because it's on the outermost, or they'll say 6 because the d is the last orbital written. But the d electrons so the 3D is part of the 3s and 3p energy level because of the 3's out in front. So the highest energy level is labeled with the number out in front, the 4. So iron, its valence electrons are found on the 4s orbital, the 4th energy level. And how many electrons are in the 4th energy level? 2. So iron also has 2 valence electrons, just like magnesium. Okay? Now, when we have the number of valence electrons known, we can then do something which is called the electron dot structure, or Lewis electron dot structure. The symbol of the element symbolizes the nucleus of the atom, which contains all of the protons and neutrons, and it also symbolizes all the inner shell electrons. The dots are symbolizing of the number of valence electrons the element has around the elemental symbol. So for magnesium, it has 2 valence electrons. So we symbolize that by putting 2 dots around the magnesium. Now, these dots can go in either the top, the bottom, the left, or the right of the symbol. Okay? One other notation is when we put dots around these element symbols, we put 1 dot at each of the 4 locations before we start adding a second dot, much like doing Hund's rule with electron configuration. Iron also has 2 valence electrons, so we put 2 dots in 2 of the 4 corners. But if you have an element like nitrogen, nitrogen has got 5 valence electrons. How? 1s2, 2s2, 2p3. The first floor has got electrons and the second floor has electrons. Because both the s and p in 2 have the shared second energy level, we've got 2 electrons in the s and we got 3 in the p. There's a total of 5 electrons in the second floor. Therefore, it has a total of 5 valence electrons. So yes, you do have to add, if the highest number out in front is in multiple orbitals, then you've got to add them all up. Okay? So nitrogen has 5 valence electrons. So how do we put 5 electrons around the nitrogen symbol? 1 electron, 2 electrons, 3 electrons, 4 electrons, 5. So you would have 2 dots in one location and 3 single dots in the other 3 locations. And right there is the electron dot structure for the nitrogen atom. It has 5 valence electrons, and things like magnesium and iron have got 2. And we can have anywhere, the number of valence electrons can be anywhere from 1 electron to as many as 8. We can never go beyond 8. So it's either 1, 2, 3, 4, 5, 6, 7, or 8 is the proper number of valence electrons. So let's go ahead and get some practice on this stuff. So we turn the page. The last time we lectured, we did all these orbital diagrams. So now let's go ahead and fill in the columns. Okay? So hydrogen has got a 1s1 configuration, okay, with 1 electron shown as an arrow. How many valence electrons does it have? Hydrogen has just 1 valence electron. It only has 1 electron, but it's on the outermost floor. Okay? So if I were to do the dot structure for hydrogen, I'd put the symbol H and I'd put 1 dot down. Now, what is hydrogen most likely to do when it comes to losing or gaining electrons? And the answer is, because it has only 1 valence electron, hydrogen is more likely to lose that electron, and therefore it becomes a hydrogen ion. And because it has lost an electron, it has 1 proton in the nucleus and 1 electron. If you lose that electron, what's left? A proton in the nucleus. So now, because it's lost an electron, it develops a +1 charge because it lost its 1 valence electron. So that's the dot structure of the atom, and that's the dot structure of the ion. Let's go to helium. Helium's got the configuration of 1s2. Its outermost electrons on the first floor, both of them are in the valence shell. The dot structure of helium, I would never test you on. I'm not going to show it to you because of the year, so I'll just kind of skip it. But helium is a noble gas. Why is helium a noble gas? Because there is no 1p orbital. The 1p orbital, there is no p orbital on the first floor. So by filling the s orbital in the first floor, we are completely full, and therefore it is a noble gas. And because it's a noble gas, it does not gain or lose electrons because it is in its most stable configuration. Helium does not form ions because it is already full to begin with. And that makes helium extremely unreactive. Okay, lithium has got the configuration of 1s2, 2s1. How many valence electrons does it have? Not 3, which some of you might have said 3. It's actually what? It's actually 1 because the second energy level has got 1 electron in it. The first energy level has got 2. The valence electrons are the furthest most energy level, which is the second floor. And therefore, lithium has got 1 dot. Because it has 1 valence electron, it is going to lose that electron when it forms ions, and it's going to form a +1 charge. So we can already predict that lithium will form a +1 charge when it forms ions. Now, some of you might be asking, how do I know if it gains or loses? The rule of thumb is this: if the element has got 4 or less valence electrons, it will lose those electrons. If it has 5 or more, it will gain. If it has 8 valence electrons, it will not form ions because it's already full. So if you have 5, 6, or 7 valence electrons, they will gain enough electrons to reach 8. If it has 4 or less, it will lose, so that, again, whatever's left is a full orbital of electrons and therefore reaches a noble gas configuration. Okay, carbon, how many valence electrons does it have? These are the electrons on the second floor, which is the outermost floor, and there are 4 electrons in carbon's outermost floor. The first energy level is full with 1s2 filled up. So carbon, its dot structure, would have 4 dots around it. Now, because it's 4 or less, as an ion, carbon would typically lose those 4 dots, and therefore it has no valence electrons left, and would have a +4 charge on it. So hopefully you're starting to see a theme. When an atom forms ions in which it loses electrons, its dot structure as an ion, it will have no valence electrons left. Okay? Oxygen, again, second energy level. How many electrons are there? 6. 1, 2, 3, 4. Double up, double up. So oxygen will have 2 doubles and 2 singles. 6 valence electrons. Now, because it's got more than 5, it wants to get to 8. How does it get to 8? It decides to gain 2 more electrons when it forms an ion. So oxygen will want to gain electrons, so that ends up having 8 valence electrons. Much easier to gain 2 electrons than it is to lose 6. And therefore, oxygen will form an ion with a charge of -2. Neon, second energy level again. They're all in the same period, so they all have electrons in the same energy level. They have 8 valence electrons. Neon will have 8 valence electrons, which means all 4 corners have got 2 dots. 2 dots is a full orbital because there's 2 electrons in each orbital. And whenever you have 8 valence electrons, you have the configuration of a noble gas. And therefore, it doesn't form ions because it is already completely filled up. Okay? All right, why don't you pause the lecture now and try to see if you can do the rest of them and see if they match my answer key. So go ahead and pause it and see what you get. Okay, sodium, the third energy level, is the highest energy level. These other guys are floors 1 and 2. So it has 1 valence electron. So sodium will have 1 dot. Because it's less than 4, it will lose that dot, and therefore will form an ion of a +1 charge. Silicon, 4 valence electrons. Oops. It'll form 4 dots, 1 at each corner. Again, it's 4 or less, so we'd expect it to lose 4 and to form a charge of +4. Sulfur, again, third energy level, we're looking for the highest number out in front of the letters, which is 3. There's 6 here. And it really doesn't matter where the double dots go. They could be next to each other, they could be across from each other, it makes no difference as long as you got 2 double dots and 2 single dots. Again, now we've got more than 5. So it's going to want to gain 2 more so that its outermost shell is full and has a charge of -2. Argon has 8 again. It is a noble gas and does not form ions. And potassium, now we get and see an electron finally on the 4th energy level. These other ones are all inner shells because they're in the 1st, 2nd, and 3rd floors. It has 1 valence electron. Potassium is the element K, and it's got 1 dot. So because it has less than 4, we would expect it to lose and form a +1. Now hopefully you're starting to notice a theme. Hydrogen, lithium, sodium, potassium. All of these elements occur in the same vertical column. We call them families. They all are in group number 1. And what do you notice about all of them? They have the similarity of having 1 valence electron, and therefore, because they all have 1 valence electron, they tend to form +1 ions because they will lose that 1 valence electron when they chemically react. And that's why we call them families, because they have similar chemical reactivity because of them having the same number of valence electrons. Let's turn the page. So go ahead now, let's go ahead and complete this chart. Again, pause the lecture. Once you complete this, it doesn't take more than a couple minutes to do that, and we'll see if you get it right. Okay? So go ahead, pause it now, and we'll see if you got them. Iron, a lot of people make a mistake with this one. The 4th energy level is right here. So this has 2 valence electrons, not 8. Iron is not in a noble gas. So when you look at your periodic table, you're looking at the very last column. These are the guys that are going to have the 8 valence electrons. Group 18 has got 8 valence electrons. Group 1 has got 1. Group 2 has got 2. Groups 13 through 18, if you look at just the 1s digit, the 1s digit of the group number tells you the number of valence electrons it has. So if you have an element that's in group 14, like the carbon family, they have 4 valence electrons. So the position of the element on the periodic table also will automatically tell you the number of valence electrons it has. So iron would have 2 dots, and therefore we would expect it to lose those. Magnesium, 3s2. Magnesium is also in group 2, the 2nd vertical group on the periodic table. It has 2 valence electrons. And therefore, when it forms ions, we'd expect it to lose 2. All right, so I fast forward ahead just so I could show you all the answers quick and not spend so much of your time. So you can always pause this lecture and recheck your answers. And again, so krypton, again, don't look at the 3D. That's part of the 3rd energy level. So we have electrons on the 4s and 4p. We add them together because they're both on the 4th floor. And again, krypton is in the very last column, the group 18, which is the noble gases, and they all have 8 valence electrons. The only element that doesn't have 8 valence electrons in that family is helium, and that's because there is no 1p orbital. It only takes 2 electrons to fill the 1s, and helium is the oddball in that situation. Chlorine has got 7 valence electrons. Again, chlorine is in group 17, so the 1s digit gives me 7, so it has 7 valence electrons. And you can also see with the configuration where you've got 3s2 and 3p5 where I've circled them, 7 valence electrons. It's 1 away from becoming a noble gas, so as an ion it will typically gain 1 more electron to get its outer shell full. Nitrogen, phosphorus, and arsenic are all in the same family. They're in group 15. They all have 5 valence electrons. You can see the ones that I've circled here in their configurations, and therefore it only needs to gain 3 more electrons to get to 8, and as ions they tend to gain 3 more to get to that. So you'll notice a common theme. The positive ions, will not have any dots around them when they form ions, and the ones that gain electrons will gain enough dots so it ends up having 8 around them and have a negative charge. So now you can see the difference between the positive ions and the negative ions that we show in chemistry. Zinc, again, the 3D is part of the 3rd floor, not the 4th floor, so it only has 2 valence electrons. Calcium also has only 2. 4s is the highest energy level. The 1st, 2nd, 3rd are lower levels. 2 valence electrons, they tend to want to lose 2. And fluorine, again, has got 7 valence electrons. It's in group 17, just like fluorine is, and therefore only needs 1 more electron to get to 8 and form an ion with a -1 charge. So this lecture is looking at how can we figure out the number of valence electrons just from the configuration. And based on that, we then can also predict when an atom forms ions. Why do we have chemical reactivity? Because they want to react by gaining or losing electrons so that their outer shells can be full. And they can either lose electrons or they can gain. And when they do that, then they start forming chemical compounds, because now a positive ion will be attracted to a negative ion, and that's going to cause a chemical bond to form. And that's through the transfer of electrons, which is what's going to be our upcoming units. All right, so hopefully you've listened, you've got a good idea on this stuff. There will be, I don't have any homework for this set, but I'd like you to do is just make sure you understand this key concept, because some of these questions will be on your quiz for this week when we do electron configurations. Some of the quiz questions will be how many valence electrons does this element have? Based on this configuration, how many valence electrons does this element have? What ion could form from this configuration? Those are types of questions you're going to see on this upcoming quiz. Okay? All right, so if you have any questions on the concept, again, don't be afraid to get a hold of me, but hopefully this makes sense to you.